So 48.2, we're going to continue the acid-base properties of the oxides of the elements in period 3. So last video, we're talking about the basic oxide and also amphoteric oxide. This video, we continue to talk about the acidic oxide. So for the acidic oxide, we are talking about the silicon dioxide, phosphorus pentoxide, sulfur dioxide, and also dichlorine monoxide. So for these oxide, they are acidic properties. That means that they're going to react with water to form acid. But do remember, not all the acidic oxide can dissolve in water to form acid. Silicon dioxide is insoluble in water. So therefore it cannot dissolve in water to form acid. Okay, that is the first property. Second property is acidic oxide. They can react with alkaline to form salts and water. Okay, so let's have a look of the first one. Silicon dioxide, we also call that silica or quartz. Okay, so actually you can find the quartz, okay, in sand as well. So you can have a look of the pictures here. So this one, okay, the crystal clear one, okay, the colorless one is the quartz, while the one here is the sand. If you take a closer look, you can find those colorless one. Okay, actually it's a small size of the quartz. Okay, so we'll say that, okay, silica, quartz, sand, okay, they are all silicon dioxide. And in chapter 9, okay, you did learn about silicon dioxide as a structures having giant covalent structures. So this one is the diagram, three-dimensional diagram you have to draw about silicon dioxide. But if you still remember, when you're talking about, you can draw it like a diamond, and then every bond, okay, we just added oxygen, will do the same. So let's show you how to do that. So you draw a 雞腳圖 first. Okay, so you draw this one first. Okay, so every connection, draw a circle there. It represents the silicon atom. Okay, so you can see that actually one silicon atom can form 4 bonding. Okay, but the silicon is not directly bond with the silicon next to it. Okay, it is having oxygen in the middle. Okay, so every single bond in the middle of it, you draw a small red dot. So this one is the oxygen atom. Okay, so this one is the silicon atom. Okay, so this one, okay, is how we draw a three-dimensional structures of silicon dioxide. But of course, okay, you can also draw something like this. Okay, but you can see that they got an angle right there. It's difficult to do. So what is this one? Actually, this one is the same as this, but we just focus on the bottom part. So imagine you remove the upper part and you look from the top to the bottom, then you can see a network like this one. Okay, so this is silicon dioxide. Just as we mentioned, silicon dioxide is insoluble in water. That one is quite obvious. If it's soluble in water, then in the beach you can't see any sand in it. Is that right? Because the sand is made of silicon dioxide. So they are insoluble in water, so they cannot form acid, okay, by dissolving in water. So this is number one, very important. Number two, okay, silicon dioxide can react with alkaline because it is an acidic base. So when it reacts with the alkaline, then they will form salt and water. So in the process, they will form silicate and water. Okay, silicate. So this one is called sodium silicate. Okay, so silicon dioxide mixed with sodium hydroxide, they will form sodium silicate and water. So you'll find it, it is so difficult to memorize this one, sodium silicate. No worry, okay. Remember, silicon is in group 4. Right above it, okay, one period before, that one should be silicon is 284. So the 124, that one is carbon. Okay, so you can imagine like this. Okay, silicon dioxide, you don't know how to write this equation. Think about this. You can write an equation, CO2. So this one is far easier for you, right? When you have carbon dioxide, sodium hydroxide. So when they mix together, you got like sodium carbonate and water. Okay, so if you can balance this one, you just replace You replace the C with an Si. Then you got the equation. Got it? Okay. So if you find the first one difficult, use the second one, okay, and then you can find the first one easier. Okay. So this one, okay, is how the silicon dioxide react with the alkaline to form sodium silicate. And for the Ionic equation, it is just like this. Silicon dioxide is a solid state, so you're not going to break it up, and you find that of course the sodium ion, okay, can be add as a spectator ions. You just remove that. Okay, so you got silicate left behind and water. Okay, so this one is an Ionic equation. So for these sections, okay, just remember how to draw the three-dimensional structures. Okay, know that insoluble in water and how it react with the sodium hydroxide will do. Next, we're going to talk about the phosphorus pentoxide. Before we move on, okay, you have to know how to draw the structures of it. Okay, this one, okay, is a diagram of phosphorus pentoxide. Okay, so this one, okay, if you take a closer look, actually more or less is very similar to a diamond structure. Again, it is the diamond structure. Okay, so you try to draw the diamond structure one more time. So for this one, okay, you can see that we have a tetrahedral shape here. 1, 2, 3, and 4. 4 tetrahedral shape. So right in the center of the tetrahedral, that one will be phosphorus. So you draw the P right here, P here, P here, and P here. You got 4 P, okay? For the rest, then it will be O, oxygen. Okay? So you'll find that you'll draw P4 and then O10 for this one. But one thing you have to remember is a bonding, okay? It's the type of bonding that you have, okay? So at 4 corner, you should have a double bond for that, okay? So you have double bond for here, double bond for here, and double bond for here, okay? So that one, okay, will be the phosphorus pentoxide. Okay, so when you draw, remember you have to eliminate this part of single bond, okay, to make it clear. Okay, don't try to do like what I'm doing right now. Okay, so this, because it will be a little bit complicated for that. Okay, so phosphorus pentoxide. First of all, okay, when we dissolve it into water, when I dissolve it into the water, they will give acid. Okay, the acid that we have is H3PO4, phosphoric acid. Okay, phosphoric acid. So again, memorize this one as 4, then it will be easier for you to memorize. Okay, so phosphorus pentoxide, when dissolved in water, they got phosphoric acid. What is this phosphoric acid? You have to remember this one is a weak acid, and not only this is also a tribasic acid, and it is a weak acid. So therefore you will find that there are 3 free hydrogen given out by 1 molecule, and also we got a reversible arrow for this. Okay, so for phosphoric acid, you have to know how to draw the acid. Okay, so for this H3PO4, basically it is like this one. Okay, H3PO4. So one of the O will be as a double bond. For the 3 of the H, they will link with the O. 3 of the H will link with the O. Okay, so they will add as OH, OH, OH. Okay, 3 different bonds. So the shape of this one is tetrahedral. You also have to remember how to draw the structures, okay, of phosphoric acid. So basically for this one, when it dissolves in water, they will give acid. Of course, P4O10, when it dissolves in, when it reacts with sodium hydroxide, will there be any reaction? Yes, because it's acidic oxide. So when it reacts with the alkaline, you see, you do the balancing like this. P4O10 plus NaOH. Because the P4O10 will first dissolve in water first, so therefore they will give phosphate as the salts. This one is coming from here. Okay, it's a 3 minus, so therefore Na will be 3. And then you have water because it's salt and water. So to balance this one, because you got 4 here, 4p, so this one, okay, will be 4 as well. So you add 4 on the right hand side. Because this one have 4 times 3 with 12 Na, so therefore you have 12 NaOH here. So for the rest, okay, you find that this is 12H, so therefore you have 6H here. So basically, if you add all together, then you will find that it will be balanced on both sides. But to be honest, I don't think you're going to have a reaction, equation required to write in the exam, because you find that we have a very large number so it's happening here. Okay, so in the textbook you can't find that, but actually P4O10 can react with the sodium hydroxide, because one is put into the water, it becomes acid, and the acid will then further react with the alkaline to give salt and water. Okay, so that is for the phosphorus pentoxide, drawing phosphoric acid, and also the structures of these. Okay, next we are going to talk about the sulfur dioxide, but before that, okay, recall your memory. The smell of the sulfur dioxide is choking smell of burning sulfur. Okay, other than that, okay, we're going to learn how to draw the structures, okay, or the three-dimensional structures, the shape of the molecules. So for SO2, we have S, it is 286, and all the O, they need a double bond, so therefore they spare 4 electrons to form 2 bond pair, and then you have 2 left behind to form 1 lone pair. So therefore you will find that we got 1 lone pair and 2 bond pair there. The shape of the molecule is a V shape. So this molecule, okay, we say that it's a V-shaped molecule. Okay, so this one, SO2, when it dissolves in water, we should learn this before. When it dissolves in water, they give sulphurous acid. This is a weak acid. So you can see a reversible reactions. Okay, and also this one is a main component of the acid rain. Sulfur dioxide is a quite common acidic pollutants, or given out from the factories. Okay, so the H2SO3 form, okay, it will look like this, the one on the right hand side. Okay, again, because you have 2H, the H is linked with the O, so therefore it will be 2 OH there, and the sulfur, the remaining O, will be a double bond. So this one is more or less like the phosphoric acid in the previous slide. Okay, so you can see there are 2 ionizable hydrogen coming out, so this one is a tribasic acid. Okay, so next, okay, it will be sulfur dioxide adding into NaOH. Okay, so this one, the product, again, it will be sodium sulfite and the water. To balance this one, more or less it's like previous slide, pretty easy. You just have 2 Na and then you just multiply by 2, and you can see the product form. Okay, so this one is a sodium sulfite. Just want to recall one of the memory. Okay, we don't have enough slide here. Okay, now we'll draw. We write on the top. So for the one you learn in fossil fuels, okay, we learn one things which can use to remove sulfur dioxide produced from the factory. That is called scrubber. For the scrubber one, okay, remember at a chimney, okay, we have sulfur dioxide coming out. We use something to wash it away. That one is also an alkaline. That one is lime water, if you still remember. So the product at that time, we still have calcium sulfide and also water produced. Okay, so this is something that I want to remind you. The second step for the scrubbers, okay, will be the sulfide add oxygen, and then they will become calcium sulfate. Okay, so this is how we remove the sulfur dioxide from the chimney, by using lime water. So that's all for here. You see that the acidic gas will have like dissolving water to give acid, and also it can react with the alkaline to form the sulfite. Okay, and you also have to remember the shape of the molecule and also the shape of the acid formed. Okay, so lastly, okay, we're going to talk about the dichlorine monoxide. But before that, okay, remember, okay, dichlorine monoxide, the color of it is a orange gas. the color is quite special, okay? Next, okay, you have to talk about the OCl2, okay, the shape of the molecules. So the Cl actually can convert like H, so not difficult. You know that Cl2O is the same shape as water. So this one, okay, is something you have to remember about the shape of it. Okay, again, this is a V-shaped molecule. Oh, so for this one, you can dissolve in water. Cl2O can dissolve in water, and the product that they form, it is not HCl. The one that they form is HOCl, hypochlorous acid. Hypochlorous acid. The one that you can find it from detergents. Okay, so hypochlorous acid. And hypochlorous acid is also a kind of weak acid, so when it dissolves in water, they will partially ionize. You'll have something like HOCl add into the water, and then they will give H plus and OCl minus. The name for this one is hypochlorite ion. Just to recall your memory, normally hypochlorite ion is a kind of bleaching agent. Okay, it will have some bleaching effect. Okay, bring it up. Okay, so for the dichlorine monoxide, can it react with the NaOH? Of course it can, and the product it form will be sodium hypochlorite as well. But in your textbook, it doesn't show again. Okay, so it will be like that. Okay, let's have some practice first. Okay, so example 48.1. So this is a typical question. A, which of the above oxide has a lowest melting point? Lowest melting point, you can find out we got an SMS here. Melting point must be related to structure and bonding, right? So we have SMS, that means when the van der Waals over there, and then we have like ionic compound, giant ionic structure, GIS. So therefore you have ionic bond. So obviously, okay, the oxide with lowest melting point should be the SMS one. And then the reason, because you have van der Waals holding molecules together. Next, okay, conduct electricity in molten state. Of course, it will be GIS because they have like mobile ion in the molten state. The one have mobile become mobile, so therefore they can conduct electricity. So I just want to draw your attention to question number C. Question C, not number C. Would each of the above oxide react with dilute hydrochloric acid, sodium hydroxide respectively? So which one will react with the acid one? Which one will react with the hydroxide one? So the acid one must be the basic oxide. Basic oxide, we got MgO. And NaOH will react with the acid oxide, which is P4O10. But other than that, Al2O3 is a amphoteric oxide. So therefore, you find that Al2O3 will be in both cases. Okay. But the question is, the most important part is, would the pH of the resultant solution higher or lower than the original before adding than the dilute hydrochloric acid and sodium hydroxide after the addition of oxide? That means before and after how the pH will change. So at the beginning, HCl original, the pH should be less than 7. But once you add the MgO, they got neutralized. So therefore, the pH should then increase. While the other side, NaOH, the pH should be larger than 7 because it's alkaline, right? So when you add the oxide in it, the pH of the solution should then drop. Okay, so this one, okay, just want to recall, I just want you to pay attention to that. For D part, we just classify the thing into different oxide, easy. And then for class practice 48.3, this one, I just want to draw your attention to C. This question is quite common. Explain why aluminum oxide is an amphoteric oxide. If you try to explain it is an amphoteric oxide, basically you just have to tell them that, because it can react with both acid and alkaline. The keyword, okay, I think you should mention the word both. Okay, both of them. And then we'll also look for the name of the salt. If it is a sodium oxide react with hydrochloric acid, the salt should be NaCl, sodium chloride. While the other one, okay, you have like react with the sodium hydroxide with the sulfur dioxide, sodium hydroxide, sulfur dioxide. So sulfur dioxide, when you get into the water, the one that they form should be sulphurous acid. So therefore, this will be the anion part, this will be the cation part. Okay. What you need to do, okay, practice your equations writing, because you need to write a lot of this. So you can see part 2A, okay, phosphoric acid, potassium hydroxide. So therefore you have potassium phosphate coming out. And then the other one, hypochlorous acid, sodium hydroxide. You will then have sodium hypochlorite. Okay, so you have sodium hypochlorite. These kind of equation writing, okay, want you to pay attention to that. Okay, practice on your own. Okay, I'm not going to spend time here. Last one. Okay, MC quite often to see this statement. Metal oxide are basic. Non-metal oxide are acidic. Comment on this statement. Remember, whenever you say comment, you have to agree or disagree. You think that correct or incorrect. Okay, the answer right here is not that good. Okay, we'll just get into it very quickly. So first of all, non-metal oxide is acidic. Remember this. We draw this, right? The non-metal oxide part. Okay, these are the acidic oxide. We say that the one on the left hand side, metal oxide one, is a basic oxide. But it's not a must, because right in the middle we do got amphoteric. The example that you have is Al2O3. If it's Al2O3, it's still a kind of metal oxide. So is it a must to be basic oxide? The answer is no. Okay. However, this one, okay, why I say I'm not quite satisfied with the answer, because they say that partly correct. It makes the things quite confused. When you answer comment on the statement, you just say agree, disagree, correct, incorrect will be all right. Part of that is incorrect. You just say that incorrect. Okay. So this statement I would say incorrect, because okay, metal oxide can be basic or it can be amphoteric as well. So the modification of the sentence should be like this. Last one, okay, it will be the summary, okay. So remember, you have to know the stoichiometric composition. Some of the elements, they may have more than one form of oxide. The one showing right here, okay, is the oxide that you have to remember. And the nature of bonding, it changed from ionic. When you go from the left to the right, ionic decrease and covalent increase. Okay, when you move across the period, okay, the ionic bond, okay, the ionic nature will decreases, okay, and then it will have become less ionic and become more covalent when you move to the right. The structure of that, okay, we'll have like GIS for the metal oxide, and for the silicon dioxide is GCS, so we'll have a very high melting point. And the rest of them is SMS, simple molecular structures. And for the behavior of oxide in water, if it is a basic oxide, they should give alkaline. However, remember there are two things which are insoluble. One is one is aluminum oxide. The other one is silicon dioxide. Sand cannot dissolve. Okay, the oxide layer on the window, on aluminum window, cannot be dissolved. Okay, so these two, okay, they cannot give any acidic solution or alkaline solutions. For the rest, okay, they can form a few kind of weak acid. Okay, so last one, okay, the basic properties, amphoteric, pay attention to the spelling, and also the acidic property for the non-metal oxide. Okay, so that's all for this video. Okay, bye bye.